This is RD Sharma Solution Class 12. We are taking exercise 19.26 of chapter 19, Indefinite Integrals. Now in this question, if you multiply this sec x inside, you'll get sec x and sec x tan x. So I'm keeping the e raised power x just like that and multiplying sec x inside. So you'll get sec x plus sec x tan x. So if you take this sec x as fx, sec x tan x will be f dash x because the differentiation of sec x is sec x tan x. So if you add these two, add e raised x, then it becomes a formula. It's just e raised x fx plus c. That is your final formula. So fx in this case is sec x. So e raised x sec x plus c. This is your answer. So this is a very formal way. But if the question is demanding more, then we need to solve it in other way. So we'll take that e raised x fx, which you find out from here. You know already what is fx and what is f dash x. So e raised x sec x equals to t. We just assume it to be t. Then we'll differentiate both the sides. So e raised x sec x will be sec x tan x. Sec x will remain like this. Then e raised x will be e raised x. And this will be equal to dt by dx. Now I'm just rearranging this. E raised x, then sec x tan x. And this is equal to dt dx I am bringing on the left upstairs. Now integrate both the sides. So first we differentiated, assuming t to be equal to e raised x fx, which is sec x, and then integration. Now you don't have to integrate because this integration is nothing but the question itself. So you can just call it as I, and that will be equivalent to t plus c. What is t? T you assume to be e raised x sec x. So this is a kind of proof also, and this is a kind of a long way of solving this question also if it demands more explanation. So this is how you have to do. All these you have to write. Okay, this is the reference. Next is, I told you that first we need to figure out which one is fx, which one is f dash x. And it may be possible that you might be thinking of fx, which is ultimately f dash x. So if you take 10x and you differentiate it, it will be only sec square x, which is not on the other side, which is negative log cos x. So you need to understand that in this question, fx is equal to negative log cos x, and actually f dash x is tan x. How? If you take fx equals to log cos x, negative log cos x, and when you differentiate it, that is when you find out the differentiation on which is indicated by f dash x, it will be log cos x is 1 by cos x will be negative sin x. Now negative gets cancelled, sin x by cos x becomes tan x, which is ultimately given in the question actually. So it's fx or f dash x, it's f dash x. So this is a kind of question which can come up to you and you need to figure out which one is fx, which one is f dash x. Okay, so the solution will be what? E raised x into fx plus c. That is the direct result of the formula if this question is equivalent to that formula or it comprehend to that formula. So e raised x negative log cos x, which is our fx plus constant of integration. You want to write it in a better way, you can just take this negative outside, e raised x log cos x, and need to put this cos x inside the modulus because you cannot have a negative inside a log. Okay, done. But if this is a question of 1 marks, okay, accepted. But if this question demands more explanation or this question carries more marks, then what you will do? You will assume e raised x fx. What was fx? Negative log cos x. I explained to you just now. So you have to take this e raised x fx equals to t. When you differentiate this, both the sides, just differentiate. So this will be e raised x log cos x. We have already done. Negative log cos x was actually tan x. I'm just doing it minus because I've taken negative outside. And this will be log cos x will remain like that. E raised x will be e raised x. And this is equal to t. Or dt by dx because we are differentiating. So this will be plus, this will be negative because negative was outside. Okay, this will be dt by dx. Now I'm just rearranging and taking this dx on the left hand side. So I'm taking ex outside, tan x will remain like that. It will be negative log modulus of cos x. And this is equal to dt, dx will go on the left, multiply this. Now the next step will be the integration. We are integrating both the sides. So when we integrate, what do we get? Left hand side is I only. Right hand side is t plus c. Integration of dt is t. What is t? You assumed it to be e raised x log cos x. So it will be negative e raised x log modulus cos x plus c. That will again be the same answer which we just explained a bit earlier. And how are we going to write this? This is the way you are going to write it. And the formula you need to remember, e raised x sec x plus log sec x plus tan x. Now again the same thing. If you take sec x as fx, the differentiation will be sec x tan x. That is, sec x tan x won't work here. So you need to take the second part, which is log modulus sec x plus tan x as fx. When you differentiate this f dash x, this log of content, whatever is there, it will be 1 by of that thing, that is 1 by sec x plus tan x, and then we'll differentiate sec x plus tan x. Sec x is what? Sec x is sec x tan x. Tan x is sec square x. I'm just doing the differentiation. We haven't yet touched the integration part. So sec x into tan x, it's not plus, it's multiplication, plus sec square x. And this will ultimately boil down to sec x only, and which you see from here only. So it's multiplication. So sec x, you can take sec x common from upstairs. You will get tan x plus sec square x, sec x, and in the denominator sec x tan x is already there with addition, and if this gets cancelled, you only get sec x. So f dash x also we got, this is fx and this is f dash x. So e raise x fx plus f dash x, this will give you e raise x into fx plus constant of integration. So e raise x, what is fx here? Log modulus of sec x plus tan x. So log modulus of sec x plus tan x plus constant of integration. So this is your direct result, and this is way you have to solve. But if someone wants more explanation or tells you to do it in another way, so we'll take e raise fx equals to t. What is fx here? It's log modulus of sec x plus tan x. So we take e raise x log modulus of sec x plus tan x equals to t, and then we'll differentiate both the sides. Apply the product rule here. E raise x we have differentiated, so it will be log sec x plus tan x. Now log sec x plus tan x we have already differentiated just now. It was simply sec x, we already did that, so you don't have to do it again. Just write sec x here equals to dt by dx. Now take this dx from the denominator of the right hand side to the left. So e raise x, I am taking e raise x common, you will get sec x plus log modulus of sec x plus tan x inside, and this will be equal to what? Dx I have already taken on the left hand side. Now the next step will be integration of both the sides. When we integrate this, first we differentiate it, then we integrate it. But this eventually is I only. This is our question only. So when we have this question, I can be equal to integration of dt will be t plus constant of integration. T was taken as e raise x into fx. Fx was log modulus of sec x plus tan x. So you can just write it like this: e raise x log modulus of sec x plus tan x and plus constant of integration, and that's your final answer. So either way or other way, both ways you'll get the same result. So this is the result which I was talking about. This reference you can keep in your mind so that you can solve it like this: e raise x cot x plus log sin x. Now what will be fx and what is f dash x? If you take cot x, it will be negative cos x square x, and that will not fall into the category or any formula equation, because we need fx plus f dash x and followed by or preceded by the multiplication of e raise x. So we'll take fx equals to log modulus of sin x. What is f dash x? Log sin x is 1 by sin x, and sin x will be what? Cos x. So you got cot x. So now it is clear, fx is log modulus sin x and f dash x is actually cot x. So just think over it, because there can be fx and f dash x which are in a swapped manner presented to you, and you need to figure out that. Now what is the direct result? E raise x into fx plus c. Fx is log modulus of sin x plus c. This is your answer. You can stop here and you can just proceed if you are convinced by this. But if this question carries more marks and it needs more explanation, then we ought to assume this e raise x fx equals to t. What is fx? Log modulus of sin x, which we have identified already. Now we'll differentiate both the sides. So e raise x. So I'm differentiating both the sides now. Log modulus of sin x, because e raise x is differentiated in the product rule, and the differentiation of log sin x has already been done in this part just a bit earlier. So it will be cot x equals to dt by dx. Now e raise x you can take common, so it will be cot x. I'm just rearranging just to match the question. So cot x plus log modulus of sin x equals to dt, but dx we have already brought on the left. Now next step will be the integration of both the sides. Let's integrate these two. Now when you integrate this, you see that this is the original question we were talking about. So this you can just write as I equals to integration of dt will be t plus constant of integration. What is t here? e raised x log modulus of sin x. So e raised x modulus of log modulus of sin x plus a constant of integration, and that's your final result. Either way, the same result is going to come, and this is what you need to follow, because this is the way you are going to refer and write and solve this question. And this question, e raised x, x minus 1 by x plus 1 whole cube. Now this is an example of certain questions which we are going to do where the formula which we want to apply doesn't fit directly. So we need to simplify or rearrange the question in certain way so as to match the formula we have already seen. So we need to match it with e raised x fx plus f dash x, since we just have e raised x into certain term which is not in the form of fx plus f dash x. So we need to change this x minus 1 divided by x plus 1 whole cube in a form which we can relate it to fx plus f dash x. So let's first simplify this. You already know that x plus 1 is in the denominator, so you need to have a x plus 1 in the numerator. So just add a 1. If you are adding 1 by yourself, you have to subtract 1 as well. And denominator remains the same, x plus 1 whole cube. Now separate these two terms, x plus 1 divided by x plus 1 whole cube, and this will be negative 2 divided by x plus 1 whole cube. Okay, this gets cancelled. 1 by x plus 1 whole square will come, and this will be negative 2 divided by x plus 1 whole cube. Now this is becoming equivalent to, or we can relate it to the formula we have already seen of this type of question in this particular exercise. So fx is, if you assume it to be 1 by x plus 1 whole square, and if you differentiate this f dash x, it will be negative 2 divided by x plus 1 whole cube. So fx, when differentiated, you get negative 2 by x plus 1 whole cube. And when you have this formula now, and you have this fx and f dash x identified, you can directly go to the result, which is e raised x into fx plus constant of integration. So e raised x fx plus constant of integration, e raised x is already there, fx is 1 by x plus 1 whole square. So you can just write this x plus 1 whole square plus constant of integration. Now you can stop here, you can proceed to the next question. But if this question demands more explanation or have more marks to solve, then you have to actually do it in a certain different way. You have to assume that e raised x fx. For that you need to identify which one is fx. So e raised x fx equals to t. Fx is 1 by x plus 1 whole square here. So now we will differentiate both the sides, and I'm applying the product rule of differentiation here. Now we'll differentiate x plus 1 by x plus 1 whole square. And 1 by x plus 1 whole square has already been differentiated, which was negative 2 by x plus 1 whole cube. So after differentiation of 1 by x plus 1 whole square, you get e raised x multiplied by negative 2 divided by x plus 1 whole cube. So I have tackled the signs also. So you have a negative here. And this is x plus 1 whole cube. And this is equal to dt by dx. Now you can take e raised x common here. When you take this common, it will be 1 by x plus 1 whole square minus 2 by x plus 1 whole cube. Dx you can bring here, and dt you can keep it on the right. Now let us integrate this. So we need to integrate both the sides. So one is fx, one is f dash x. So when you integrate this left hand side is actually the integration we were talking about. We started with this integration only. So you don't have to integrate at all. You just have to write it as I, capital I. And on the right it's t plus c. See, this particular thing has come from x minus 1 by x plus 1 whole cube only. So you can just write e raised x into x minus 1 by x plus 1 whole cube dx equals to dt. So when we integrate this, left hand side is already I, which is the original integration which we are talking about. This is I only, capital I. So write this as capital I, and integration of dt will be t plus c. What is t here? It was e raised x by x plus 1 whole square. So I am writing it here. Integration become e raised x by x plus 1 whole square plus constant of integration. So these are the two ways you can solve, and then you have to just write this also in a way that you separate two terms out, one calling fx, one you are calling as f dash x. Then only the formula can be applied. This is the key of separating these two out. Next is e raised x sin 4x minus 4 divided by 1 minus cos 4x. We need to resolve again. Again, directly we cannot relate it with the formula. We have to separate them out, then we can relate it with the formula of e raised x fx plus f dash x. So sin 4x by 1 minus cos 4x, and 4 divided by 1 minus cos 4x. Now 1 minus cos 2 theta or 2x is equal to 2 cos square theta by 2. So it will be 2 sin square theta. Whatever angle is on the left, the angle on the right will be half of that. Now sin 2 theta is 2 sin theta cos theta. So whichever angle is on the left, which is 2 theta, is divided by 2. Now what is sin 4x? It will be 2 sine 2x cos 2x. You can use theta or x because we are dealing with x, so let's keep it as x only. 1 minus cos 2 theta will be 2 sine square 2 theta in this case, because 1 minus cos 4x will be 2 sine square 2x. Minus 4 divided by 1 minus cos 4x is again 2 sine square 2x. Now you can cancel these two. Sine gets cancelled. Cos by sine is cot. It will be cot 2x. Now here 4 by 2. So 2 gets cancelled. 2 remains in the numerator. Sine square 2x will take it in the numerator. It will be cosec square 2x. Now we have come up to that juncture where we can relate it with the formula which we already know, which we are doing in this exercise. So if you take this fx equals to cot 2x, you will get the f dash x, which is on the next, which is actually the next term after cot 2x. So cot 2x is negative cosec square 2x, differentiation of 2x will be 2. So minus 2 cosec square 2x is already there. So this is fx and f dash x. Please remember, when you combine these two terms, it will be sin 4x minus 4 by 1 minus cos 4x only, because that is how we have started. So answer will be what? E raise x fx plus c. What is fx? E raise x fx was cot 2x, so just write e raise x cot 2x plus constant of integration, and that's your result. You can just stop here and you can proceed now. But if this question needs more explanation, I told you what to do. That you have to consider this e raise x into fx equals to some t. When you take it as t and differentiate both the sides, now the next step will be differentiation of both the terms. So it will be cot 2x, e raise x will be e raise x. Then I am applying the product rule, which you are already aware of. Cot 2x will be minus cosec square 2x. So cosec square 2x, you have already done that, okay? This is equal to dt by dx. Now I am just rearranging. I am taking e raise x outside, cot 2x here. This both taken outside. So negative 2 cosec square 2x will be there. And this is equal to dt. And let's integrate both the sides now. And this is actually what? This has come from sin 4x minus 4 by 1 minus cos 4x only. We resolved it and this came from the same term. This is I only. And this is equal to t plus c, because integration of dt is t only, t plus c. So I will be, what was t? We assume it to be e raise x cot 2x. So this will be plus constant of integration. Okay. Now how you are going to go about it or solve it? So this is the stepwise way. You can just pause it and have a look, or you can just take the things out of this, so that because if any of this question of this sort comes, then you can solve it. This will take in the later part. Thank you so much. Have a good one.